All right, welcome. We're going to go ahead and get started on our oscillation module. And this is why we started out by learning of translations. And essentially, to perform oscillation, what you have to do is go into what we call polar coordinates. And so, when I was first learning, I was always kind of looking, well, where's the command line to go into polar coordinates instead of our traditional Cartesian coordinates? And there isn't one. Because it's not something that you switch mechanically through, the technology. It's a frame of mind, essentially. And what it comes down to is when you're performing oscillation or doing anything with circles, any kind of oscillation of that type, you're dealing with mathematics. And the mathematics you're dealing with is trigonometry. And for those of you who have had trigonometry, those of you who are older may not have had trigonometry, but most people who are coming out of school systems now have had some form of it, such as SOHCAHTOA. That's a good one. Opposite over hypotenuse. All these other formulas come into play. And let's talk about that. How a circle can be used to work within. Here's one example of why you would want to use a circle. I'm going to go ahead and bring up a paint.net program, and I'm going to try to explain some of this through to you, and just kind of feel free to scream out loud if I'm going too slow. Let's take into consideration the Cartesian coordinates. So that first is our oops, I did it wrong. It's our normal Cartesian coordinates where we have our 0, 0 right there. And then we draw out here in the screen. Well, what if I had an object here and I needed it to know what the angle was, or anything, how I could take this object that's over in this area and get it to this object over here, or vice versa. And what ends up happening is you have to know the angle. You have to know that angle to be able to get to there. So here's kind of how oscillation works, and it's actually rather stupid simple. It's an old carpenter's trick. You go to your polar coordinates in your mind only. So let's say that this is location 100. 100. And this is your object. Oops, that's a little too many. It's not really a good circle. This is your object. So let's say that you want to draw or you want this object to move in a circular manner or rotate. So what you have to do is you have to create a circle outside of it. This is how oscillation works. And actually the circle would be, let's say that we want this object to move in this direction as a circle. Okay, and let's pretend that that's a nice circle. So here's our object and we want it to oscillate. So what that means that we have to do when we learned about canvas is that you you actually rotate the paper, the canvas, not the object. However, you can oscillate and rotate the object, but let's not get into, no, let's just stick simple here for now. What you have to do is you have to go, if you want this object to follow this circular line, you have to go into what's called the polar coordinates. And remember, that's frame of mind. You have to know what the center of that circle is. And this is what we call where we would be at our origin. This would be our origin for our circle. And then from there, all we needed to do is draw a proverbial string across by distance. So this comes back a horrible D. That's not even close to a D. So that distance, this distance, is where we go with the different oscillation type algorithms, equations, whatsoever. So just take that you're trying to rotate this object around this circle. So you find, and you go to polar coordinates, you go over here, and this is where it's key. You actually change the origin of your canvas. You translate it out to this position, 100 or 0, 0. I got off on that track. Let's just worry about that 100 later. So then what you would do is you would draw a string out and run it around like you would physically drawing a circle in real life with a center point and a string. And then you would know all the coordinates for this object to go ahead and turn around. And that's how all oscillation happens, is with that one understanding of changing your origin. Instead of being at 0, 0 up here, you change your origin so that when you rotate the canvas is going to be rotated around this origin, and the object you have out here is going to circle around or is going to move around and circle as you wish, based on you rotating the canvas. So that polar coordinate is going from, going to this position, resetting your canvas's origin to 0, 0 being right here, and then using mathematics, trigonometry, to figure out everything from there. So here's where it kind of gets the idea of oscillation gets kind of the polar coordinate system. Why we go into polar coordinates mentally is because if you are working with a new origin and everything around you is going to be based on a placement of distance and some form of trigonometric equation, which Pythagoras theorem, here's an idea right here. This is Pythagoras theorem right there. There's our triangle. So if we know out these values, we will know this value. So essentially all you're doing is drawing triangles across to find what you need to find. It's really kind of cool because you really understand that no matter what you deal with, and when you're dealing with polar coordinates at an origin point, if you need to know from this origin point anything that is circular or any kind of circular equation or formula, you got to think about the back end of what's going on in trigonometry, which unfortunately this course is well, fortunately, not unfortunately. Fortunately, this course does not mean you have to have trigonometry. It's not a prerequisite, so we can't actually go into instruction of trigonometry. But it's that idea, that knowledge of that if you want to do oscillations, you've got to actually change the origin of you got to do what's called a translate. You do the translation, change the origin, make the new origin the point you want to oscillate around. Then you can oscillate around in a circle by drawing multiple, or by not by drawing, but just knowing that everything that you're doing around this circle is a triangle. That's all it is. It's really that simple. It's really that simple. It's a triangle. All, everything that you do mathematically is just a triangle, no matter what, as you go around that circle. And that's why you go into polar coordinates. That was the whole point for this whole bit, is just, hey, why do we go with polar coordinates? Well, because all equations that deal with oscillation in circular mathematics, well, duh, we know what that is. It's trigonometry. So you can use your SOHCAHTOA, opposite over hypotenuse, blah, 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 equations, cosine, sine, all of these equations to work with, because you are in your own frame of mind, not technology-wise, just the way you're using the technology. You've switched to polar coordinates, just in your mind. So whenever you actually perform a translation for oscillation, that is going into polar coordinates. And then you restore the context back to its original origin after you've done your rotation. And you're good to go. So what you want to do is, if you're performing an oscillation, you will translate out your origin. You will do whatever mathematics you need as far as, angle and whatnot. And then you will perform your rotation only on what you want. Then you restore the context, because you don't want to do any more rotations. So those are some of the steps that you do. First, translate to it. Well, first save your context, translate, change your origin, and then perform your rotations. Okay, so polar coordinates, why do we go into them? Well, because everything that we do is going to be an equation in trigonometry of a triangle. And if we want this to go out further, well, then our triangle just goes out further that we're working with, and our circle does. So yeah, horrible drawing, but that's kind of, I wanted to get you an idea that polar coordinates are not a line of code you write or anything. It's a mental understanding. It is, you do something technologically for polar coordinates. You do a translation to change your origin, and therefore you can now oscillate around that origin for any kind of distance you want. Okay, so that went a little bit off. Okay. Let's go ahead and talk about an object that you want to rotate about its axis. Okay, so let's say that this screen is our original coordinate system. 0, 0 is up here. And let's say we have a square. And we want the square to just spin. Okay, so what that means is that we have to translate our origin and create a new origin right here. And we have to draw, since this is a 0, and this is very important here. This is our new 0, 0 is here in the middle of our rectangle that we're going to oscillate. So when we rotate and then draw on this canvas after we translate it first, then we rotate the canvas. The canvas gets rotated, then we draw the square. What you got to consider is that the drawing of the square needs to happen. Let's say that this square is 100 pixels wide by 100 pixels tall. 100 by 100 pixels in size. So since that you translated your new origin and you're now thinking in polar coordinates, when you draw this rectangle, you have to do it with the location -50 for the x location and -50 for the y location. But why? Well, because your new 0, 0 is right here. And since we know that rectangles always draw in their upper left-hand corner, we got to tell it that since we're at 0, 0, 0, right here for our origin now, we've moved our origin from up here with our translation because we have to do that to go in polar coordinates so that we can deal with distance and triangles around us. We now draw at location -50, -50 because half of 100 is 50. This right here. Half of another 100 is 50. So you actually you move where you're drawing from, and you draw right here with that -50, -50, because you're at location 0, 0 here. That is a 0, 0 location now, because you translated it, because you're in polar coordinates, because you can't do anything with oscillation without being in the middle of a circle and able to work with triangles. All the way around triangles, multiple triangles, all the way around that circle, so that you can do equations with that circle. Or within that circle. Or actually outside. Okay, so this is kind of the big idea, is that when we are going to rotate something, we got to go to the polar coordinates. We got to translate to the origin inside of the square. Then we have to rotate it, and then we have to draw it with the polar coordinates, which means that since we've translated 0, 0 after we've rotated the canvas, remember we rotate the paper. So think about this whole screen just being rotated. We rotate the whole screen, but we got to tell it to draw at -50, -50 because our 0 point is right here. So then it draws right here, and then we rotate it, and it rotates around the origin, and we've performed our rotation. So whenever you do a rotate of the canvas, it always rotates around the origin. So if you do any old rotation of the canvas, it's going to rotate about this origin. So let's take, for instance, if we want to, let's say, take an object, rotate it around in a small circle, we would have our origin right here in the middle. If we want to rotate it around a larger circle, we would have our origin right here. If we wanted to rotate it in another location around a small circle or a large circle, our origin would be right here. And from there, it just becomes a distance equation. And you guessed it, more triangles. I think I'm drawing these triangles wrong. In any case, that's oscillation. That really is it. It's much more, well, of course it's more difficult when you're doing it because you're dealing with things on the screen. Maybe you're only rotating one item. So just remember that kind of key understanding that when you go into polar coordinates, it's not something that you physically do. Well, yes, it is. You can consider translating your origin going into polar coordinates, if you will. But it's a frame of mind. And what it comes down to is that if you want to do any kind of oscillation, you have to do it always from a point or an origin. And from there, the circle just becomes a matter of distance. How big is your distance out from that origin for your circle? So let's say that we wanted to translate or we wanted to move something around in this type of arc. Let's do just a thought experiment. If we wanted to rotate something on the screen in this arc, that's how we wanted it to move. What we would then have to do is then we would have to translate the origin to the center of this arc. Then we would need to know the distance that the object is going to move in that arc. That would be a number that we would just come up with. And then we would be just like drawing the proverbial string from our new origin and making that object move around this arc. So our first step is to translate, put the origin here. Our next step would be to rotate the canvas. And then we would draw. However, we would know that our point of origin is now here. So we would draw at a coordinate that we derive from a distance equation within trigonometry. So it really comes down to, you're just a man in the middle or a nail in the middle and a string. And you put a pencil at the end of the string and you draw a circle around. Okay, enough. Let's go have some fun. Read more into your book. There's a lot of stuff on oscillation, guys. But it really is, you got to be thinking polar coordinates. And that's how and of course that negative value for drawing. When I first saw that, I was just like, what? I have to do a negative value for drawing an object on a screen? Well, it's all because you have to go to that middle. And this becomes the new origin, 0, 0. And it's just kind of like that rectangle example. Okay, so let's go. Enough. Let's go have fun. All right. Don't save. Okay. This PowerPoint is absolutely rubbish, so we're not even gonna go through it. All right. So here's your task deliverable. I have a template provided for you. So we're gonna go ahead and get that template to get that going. I'm gonna actually. This is going to be the HTML5 template chapter 3 oscillation assignment 1 zip file. It should also be available in your modules. I'm going to go ahead and get it set up and then I'll be back. Okay, and we're back. We have our template downloaded and put it into NetBeans. It should be HTML5 application _ chapter 3. And we have 4 files in here. We have our index, which starts with our math vector, that's our p vector class or our vector class, our mover class, and our normal game programming class. So the first thing we're going to do is let's go ahead and tear out anything that we don't need, and then we've got to repair the math vector class, and then we can get into our steps. So we're going to go ahead and go over here to my canvas, and let's see what we don't need. Well, we don't need anything time-based or frames per second based, so let's just go ahead and get rid of that. And we're going to need angle, velocity, and acceleration variables. Angle, this is for the angle. This is for an angle velocity. And this is for an angle acceleration. So they've got the same relationships as your angle, or as your vector location, and your vector location, your vector velocity, and your vector acceleration. So they've got the same type of relationships. An acceleration, anything that is referring to an angle as a coordinate or an angle that's being changed. You have the acceleration of the angle, or the change of the change. You have the change of the angle, which is the velocity, and then you have the angle itself. Okay, we're going to use the ellipse. We're going to draw some ellipses. Let's fix this. Let's get rid of this diagnostics. And let's fix this so it doesn't do the silly, stupid thing where it has an upper bar that doesn't refresh. Okay, we'll do that. Okay, so just get rid of those. Make sure this is 0, 0. Okay, our update function, all it's going to do, just like our other vector, velocity, acceleration, and location, is the acceleration or the acceleration of the angle is going to change the velocity, and the velocity of that angle changes the actual angle. So it's the change of the change. That's your acceleration. The change of the angle is your velocity, and the angle itself is just called angle. So this is just something that's moving around in a circle, and the angle I mod by 360 so that if we're always increasing an angle, as we know that an angle goes from 0 to 360. Well, if an angle coordinate goes into the value 361, that's just the value 1 for an angle. We know it's only 0 to 360. If we say 361 or as an angle, we actually mean angle 1. It actually works with you can input the value 361, but here's the thing is if we're always doing a count, that count has to be constrained within its real life values. So we don't want to send an angle of 10,544 to our rotation function because it's whenever you have an upward basically a variable that's increasing in size, you don't want to allow it just to go run amok. There's a point where your memory, the memory for a particular variable will, and we call that your static memory. Your stack memory will blow the stack. You'll go outside the amount of memory you have. So then we have our draw function, and that doesn't look like we'll talk about this stuff here in a little bit. But that doesn't look like it's doing too much that we need to get rid of. Here's our calc FPS. Let's just get rid of that. We don't need it. Okay, and then we go down diagnostics we don't need. We'll get rid of that. Okay, so cool. We just have our, okay, we don't need to do calc FPS. We just, we have a clear canvas function. Okay, that's fine. Clear the canvas, update, and then draw. All right. Okay, so let's just look at what this code is doing right now, currently. We have a update and draw function. Now, what the draw is doing is first saving the context, then it translates. This is when we go into polar coordinates. Now, you notice how it translates to the canvas width divided by 2 and the canvas height divided by 2. So essentially, it's going into the middle of the screen. And then we rotate the context. Now remember, it's rotating your paper here. Even though we're saying context rotate, it's rotating the canvas. So we translate, and the middle of the screen becomes our point of origin. Okay, let's bring up our drawing program that I'm horrible about. Okay, so here's our screen. We are going to, instead of having our 0, 0, oh, for some reason I got thicker lines here. That might be even better. I must have hit something. Oh, I hit the paintbrush. Okay, well, I guess that works. We'll keep the paintbrush. Okay, so instead of our origins being an upper and left-hand corner, we're going to translate into the middle of the screen. Here's our new origin. Now we can kind of consider ourselves in polar coordinates. Now here's the key. You always want to save your context before you translate, because you only want rotation to happen in areas that you want it to rotate. So once you rotate the canvas by a specific degree, it takes and it turns the whole drawing surface by that degree. It can be either clockwise or counterclockwise. We use negative numbers. Negative number versus positive will go in one direction or the other for your angle. And that's a 0 to 360 value. Actually, I just totally, that's so stupid. Yeah. You can have negative values for your angle. But an angle of 0 to 360 by its nature is no negative. But yes, you can. It just means to go in the other direction starting with your count. So a negative 180 and a 180 is the same point. Okay. If we are doing some kind of, there's an issue. We don't need to do a begin path there. Okay, so here is where we draw an ellipse. Then we move to, and we do a line to, and then we draw another ellipse. Okay, so let's run this. Now let's see what it's actually doing. Oh, we got to go fix the vector class, don't we? Okay, well, let's just finish up talking about this, and then we'll go fix the vector class. All right, so we rotate the angle around our translated middle. So let's go back to here. So essentially, the whole canvas, this whole piece of paper, will be rotated about this middle. All right, let's go fix the vector class, and then we're going to follow some steps. And of course, we'll talk about the code as we go. Okay, so the fix it on the vector class. It's just the same fixes as last time. We have this add function, and remember, I was talking about one add function being stinkier than the other. This add function is the better preferred way of doing things because we're not creating new memory. So let's just get rid of the poopy one. Keep that add function. Let's get rid of the poopy sub function. That has the same name. Okay, and let's see if there's anything else that has the same name. Looks like this one. Let's get rid of the poopy one. Okay. All right, so we got rid of the div, one div function of the same name. The same thing with the add and the sub functions. Those are the two fixes that we need. We may have to come back because I've been having issues with these functions. We may have to come back and play around here in a little, as we progress. But that's all we need to do to fix the math vector class. All right, now let's test to see if it'll actually do anything, and then we'll debug and see what's going on. Okay, so something's not happening. Let's go to developer tools and let's see what's wrong. Now is not defined. Okay, yeah, too much hack and slash. All right. So let's go in the game loop and fix that. So we get rid of these two lines in the game loop. Okay, now let's see if it does something. Oh, cool. Okay, so it's doing something. All right, so let's talk about the code okay, so since we our origin, we put our origin here in the middle, and we do a draw line. Okay, so let's look at this draw function. Actually, everything's happening in here in the update and the draw. Our angle that we're using is continually changing and just going from 0 to 360 and then back to 0 to 360 again. So the angle is just going around and around and around. 0 to 360, 0 to 360, 0 to 360, 0 to 360. And that's what it's doing as it spins around here. But you can see it's going faster and faster and faster. That's because our angle acceleration is being increased by 0.001 each frame. So it's going to, the velocity of the angle is going to increase through time, which is going to increase the speed of the angle that we're using to do our drawing with. So that's all this update does, is literally take angle from 0 to 360 over and over again, but it does it faster. It does it faster. It increases in speed as it progresses. This is where all the magic is happening. We're going to save our canvas. We translate into the middle of the canvas. Then we rotate the canvas by the angle. And here, right here, this move to x minus 50, x plus 50. And here, what is x? Oh my goodness, x is 0, 0. So what do you mean? If we're drawing an ellipse at location 0, 0, which is what x is every time, what the heck is going on? This thing is in the middle of the screen. It's not at location 0, 0. That's nowhere near 0, 0. Well, duh, that's because we translated it. We changed our point of origin. Instead of 0, 0 being up here, we translated this location or this origin to be the middle of the screen. Canvas width divided by 2 and canvas height divided by 2. So now our 0, 0 is right here. Okay, so it starts. You see how it starts right there, just like that? That's all it is just a line. So when we do the line 2, and let me just do this. Okay. Okay, so here's kind of where we start out with. We do a translate to canvas width divided by 2, canvas height divided by 2. So our new origin is right here. This is our new 0, 0 point. So 0, location 0, comma 0 is now right where this circle is. Okay, then we rotate. So that means that the whole paper rotates. So if I could take this window and rotate it around this middle, that gives you an idea of what we're dealing with. You're rotating the paper, not the pen. Okay, so when you rotate the paper and then you draw to it, you're drawing something now that is been moved by a specific angle, thus affecting rotation. So when we call for an ellipse at x and y here, and the height is just 8 pixels, what we're doing is, since our point of origin is in the middle of the screen, is we're drawing that ellipse into the middle of the screen, which it is right here. But here, this line right here, context.move to x minus 50. What? Okay, so what we're doing is we're saying go to x, which is here, and subtract 50 and go to this location, and then do a line to x plus 50. Since x is 0 right here, plus 50 means here. So we say do a line from here to here. That's what this x minus 50 is for, which is essentially just minus 50, since x is 0. But that's the idea, is that when you move your origin to 0, 0, this is now 0, 0. We do a minus 50, you start drawing here if you're doing an x minus 50 on line 54. So we move to this location, and then we do a line to x plus 50, which is this location, since x is 0. But since we rotated the paper, what we're going to see on the screen after it's done drawing the second ellipse, which is just overlaying the first ellipse, is we then restore the context and we go back. Our origin is back here to the upper left hand corner as we're used to. Therefore, we can now begin with any other kind of processing, such as maybe doing another rotation on something. But we've rotated the canvas when we did that draw, thus affecting rotation. And that's what's doing everything. That's what's doing the whole job here, is that draw function. And that's all it's doing. Is rotating. Remember, you rotate the paper and not the pen. All right. So let's get into your steps here. First off, let's just take a peek at this thing because it's kind of cool. Let's do a what if. So let's do another thought experiment. What if I did a negative 100? Well, then play with it. That's the whole idea of this is let's do a negative 100. What do you think it would do? Well, find out. There we go. There's our negative 100. It just goes back further. That's all, as expected. So remember, your drawing and everything doesn't change it. What you're rotating is the paper. You're rotating the whole canvas here. Then you go back to your normal coordinate system. So when I said that you don't make a switch mechanically for polar coordinates, I wanted to kind of emphasize more of it's a mental exercise, because you actually do when you translate. That's kind of going into polar coordinates. If you know, it's not the perfect explanation, but it really is more of a frame of mind. And you've got to be thinking about your trigonometry and your SOHCAHTOA. Then you have things like determining the angle between two objects, and that is determining the arctangent. So if you want to find the angle between two items on the page, that's an arctangent calculation, where it's a calculation that requires the arctangent. Okay, let's go through our steps. Let's bring it up. Okay, step 1. Edit your mover class to contain these variables. Okay, we've got that. Create an array of movers in my canvas, much like you did in chapter 2. Oh, okay. Well, the code's already here, so let's just copy and paste it. Oh, wait, no, we need to do assignment 1. That's assignment 2. It's a whole different template. What am I doing? Okay, let's do assignment 1. Okay, we're going to do this. We're going to modify line 57 for the ellipse. Okay, modify function call for drawing 2 ellipse shapes. Modify each ellipse so that they are drawn at the end of the line. When you are done, it should look like the picture below. We only have to modify 2 lines. Okay. Line 57 to 60. Okay, so let's go ahead and look at this ellipse. Mine's 57. Boy, oh, because we messed with the template. So the lines are different. So it's this line, 53, and 56. 53 and 56. And what we need to do is we need to draw them so that they're on the left-hand side versus the right-hand side. Well, we're gonna move on to template 2. I'm just gonna give you a hint here. Since your origin is here, wouldn't you have a negative number to draw your ellipse here? Like, for instance, x minus 50. And since your origin's here, wouldn't you have a positive number to draw over here? Like, for instance, x plus 50. Because 0, 0 is here. And that's what this assignment is about, is to get your understanding of that. So you're going to modify lines 53 and 56 after we took the bloat out to complete this step. I want to get on to the next step because this one's much more lengthier and I want to get you a good start on that. So we're going to go ahead and close this all out. I'm going to take a quick break, and then we're going to come back and we're going to work on assignment number 2. Okay, you should have your Chapter 3 Oscillation Assignment 2 downloaded and opened up in NetBeans. So you're going to actually use a different template. You're going to use this a template right here for your assignment. Our index has Math Vector Mover in my canvas. Math Vector looks like it has been... We may have to fix this. Let's leave it alone for now, and we'll come back to it because it may need, because we got these two functions, or actually 4 functions that have the same name, that and the div ones. Even though they're used differently, the compiler gets confused between the two. In fact, let's see, can we just comment them out for now? Because we may need to go between one versus the other. Okay, so let's comment out the poopy one first. The one that has bad and poor memory management. Instead of reusing memory, it's actually creating more memory. Okay, so let's get rid of that. Sub. Okay, and the add. And yes, if you're asking yourself, I left it in here intentionally for a good teaching moment. Or for repeated teaching moments. Never use the new if you don't need to. Okay. Alright, so math vector is good. Let's go ahead and hack and slash on the same stuff here just to... let's get rid of, zoom in on it, let's get rid of our date stuff that we don't need. Let's get the diagnostics done. Let's fix the clear canvas, 0, 0. Okay, so we have our update step. Okay, it looks like I put in where we need to do steps. Step 2 here, create an array of movers. Okay, it looks like I probably don't have where step 1 is. Step 3 here is setup, so that's a setup function. So that's obviously the setup function is going to be called somewhere. Let's get rid of the diagnostics. Don't forget to get rid of this now and now at last animation frame. We don't need that. We don't need the calc FPS. Okay, I think we got something. Oh, it looks like setup is called right here. We probably should, this just doesn't make sense to put it there, but yeah, I did before the window call, before our game loop starts. And that includes our first window call, so yeah. No, it doesn't need to be there because it doesn't happen until the game loop happens. And remember, the game loop is called automatically on its own because of this special syntax. So the setup function is called before the game loop starts being invoked. And it's for setup. Probably to do our array of movers. Okay, so let's go ahead and see what this actually does. It does nothing. Cool. I'm pretty sure it does nothing. All right, so then let's go back to our assignment and look at our first step. Okay, our first step is to put in some variables. We got to put in these 3 variables so that we can handle some oscillation speeds or some an angle that's going to go from 0 to 360, back to 0 to 360, back to 0 to 360 over and over and over again. So it's just basically a clock move in circles. Okay, so we're going to take that, step 1, and we're going to put that, we got to put it in our mover class. Because we're going to draw rectangles and make them spin. That's what we're going to do. Okay, so we're going to put this, and our rectangles are going to be movers, I think. Okay, So step one, and we're going to go to the mover class. Okay, let's go into the mover class. Okay, so here we go. Our mover class is everything that we've been learning about so far and that we've dealt with. So we're just going to pop it into our mover class for step one. And that means that every mover that we have is going to have an angle speed. Let me a rotation speed. Okay, so this is just going to be the speed of rotation here for our mover that's going to be a rectangle. So remember, that's mover.js right in our mover class constructor or start of our mover object, where it says step one here, blah blah blah. All right, let's go back to our steps. We're going to create some movers. So this array is actually let's create our mover array. So we're going to create an array of movers, and let's do that at game scope. Let's do that, and in fact, you know what? Let's do it at game scope, and let's do it at the file scope of the game. So we're going to do that in my canvas array. So create is the wrong term. Define. Or actually, no, create, because you're creating the first pointer. So you're just not. You need to then create the movers inside of that pointer array. Okay, so step two, create an array of movers. That's line right here that we're going to put in our array instantiation for our mover. Now we've got to create the actual movers after we've created our array. So then we're going to go in and go back to our instructions. Step three, initialize your movers in the setup function, which is already called. So we're going to go down to here, to our setup function that's called down here before the game loop gets started. So we do step three here. Okay, so what this does is just instantiates the movers. You have to have the array created first, and then for every index in the array, you create a new mover. Now what we're doing here for creating new mover is it looks like that we're doing a random number and 0, 0. So a random number for the first argument and 0, 0 for the second and third argument. So let's go to the mover class. It looks like we're sending it a different mass for each one. And then we're sending it the starting origin, which is 0, 0. And mass is going to be dealt with later when we'll use it later. We may not use it. We'll see. Okay, so we got our setup function done. Let's go back to step 4. This is going to be our update function. So inside of our function, our update function, all we're going to do is update the movers, and it looks like draw the movers. So we got to do that, the update for our movers in our update function. Since we've already instantiated the movers, and that means that we declared the array and we instantiated them through the setup function. So here is our instantiation of the movers after our declaration of the array in our setup function. Now we need to update those movers. We're going to call the update function for each mover. And then we're going to call the draw function for each mover. So let's go ahead and grab the draw code. Okay, step 4 right here. There we go. Step 4. Oh, we're not using Calc FPS. That can get gone. Okay, so we've declared an array. This step. Instantiated the movers in that array. This step. Now we call the movers update and draw functions. So we should have maybe something on the screen. Not yet. We'll get there. Okay. Oh, probably because there's nothing in the draw or the update functions of the mover. Okay, so let's go into obviously step 5. In the mover, your update should update the angle, velocity, and angle acceleration. Okay, so we're going to grab just all of this. That's step 5. That's going to be in our mover update function. And what it's doing is it's taking and dealing with the velocity location vectors based on the acceleration and velocity. And it's dealing with the angle acceleration and angle velocity variables and setting the angle based on that. So remember, it's just values going from 0 to 360, 0 to 360. Then it looks like we are going to constrain the angle velocity. That's interesting. Did I build a constrain function? Okay, that might be in the mover. Let's go ahead and just grab it and look. Oh, this last one, this dot acceleration dot multiply 0. What this does is it just sets the acceleration back at 0 like it should be every time through your loop. So I'm in the mover code here now. And inside the mover, it looks like I'm going to put our update code right here. Okay, and this one is the one that is warring constrain. What are we doing with the constrain function? Is that even a code that works? We're going to find out, it looks like. I don't see it anywhere in my code, constrain. I don't think it's JavaScript, is it? Constrain, is constrain around here? Oh, there it is. Oh, I just send it an angle velocity and a low and a high number. So I'm telling it to constrain a value that I send it to a specific low value versus high value. So I send it the current value. Okay, so now I can explain that. Okay, so let's go ahead and go back to the mover class. So what this constrain does is it constrains the angle velocity between a -3 and a +3. Now, a -3 will rotate in the opposite direction as a +3 when you're dealing with rotation. So if you have a negative value for your rotation, I believe it goes counterclockwise as it should. It's negative. And then if you have a positive value for your angle, it's going to be moving in the other direction, clockwise. Okay, so that just takes the angle velocity and constrains it. And then this acceleration basically just takes the acceleration x value and y value and sends it to 0. So if you look in the math vector class, you'll see this molt 0. And if we look for it, we'll find the molt 0 in here somewhere. Here it is, 0. And then what? 0 comes in, x times 0, y times 0, which is 0. So it just takes and just resets it resets those values back to 0. Okay, so we got the update function done. Now we're going to do the draw function. So let's go ahead and go into our draw. Then we're going to play with it. Step 6 draw. Okay, what does step 6 do? All right, here's what step 6 does. Is it looks like it takes the location of the mover, multiplies it by the mass and 16 divided by 2. It looks like we might be... Oh! Mass is used for the size. So you see here that when we do a rectangle, that we take it and we use mass times 16. Okay, so when we created these movers, over in the game loop, in the setup function, notice here that we are getting a random number between 0.1 and 5 for the mass. So that means that the rectangles are going to have a random size, because when we draw the rectangle size is going to be the width and height of the rectangle's mass times 16. So that means if we want to translate to the middle of the rectangle that's being drawn, we have to translate it to the location of the rectangle plus the mass times 16 divided by 2. Okay, let's go in and just talk about this, because the movers are rectangles essentially. Let's go into, the drawing program. Let me kind of explain what's going on in this whole function. Okay, so location is the actual location of the mover. And let's say that we have a rectangle out here, and we want to rotate this rectangle so that it spins. That means that for every rectangle that we have to translate the origin to its middle point. Actually, you know what? This was better like this. Okay, so we have to translate from the normal upper left-hand corner origin of 0, 0. We have to translate that origin to the middle point. So what that is since the mass is a function of the size of the rectangle, for when we draw it, we use the rectangle's width and height value with mass times 16. And let's say that the mass is 1. That means that this would be 16 across and 16 down, because the mass of 1 times 16 means the width and the height of the rectangle is 16. So we need to translate to the middle of the rectangle, and the middle of the rectangle is location X and location Y. Location X, location Y here on line 43. So then we take this location X and we add half of this 16. And we take the location Y and we add half of the other 16. And that gives us this coordinate right here in the middle. And that's what we translate to. And we have to do that because if we want to spin this rectangle, we have to go into polar coordinates so that we can rotate the canvas or the paper around this new origin. So that's what line 43 is doing here, is doing that translation. So it's location of the mover plus the randomly generated mass, which for our example, let's say was 1, times 16 divided by 2. So 16 divided by 2 would be this halfway mark. So location of X plus half of 16, which is right here, and the same thing for this dimension. So we find that middle. Then we save our context before we translate. Always save before you translate. Okay, so then we rotate about that axis an angle from 0 to 360. this dot angle never gets a value that's different between 0 and 360. It could be negative 0 to 360 also. One denoting counterclockwise versus clockwise movement. Okay, begin the path is just for drawing the rectangle. Once the canvas is rotated, we perform our rectangle drawing on the rotated canvas, so then it's going to be skewed by the angle. And that's the way it'll look. It'll actually draw on the screen after you rotate the canvas. So yeah, do that. On a piece of paper, draw a square. It doesn't rotate. Okay, well, all right, here's the deal. Take a piece of paper, rotate it, draw a square. Then take the piece of paper and bring it back to its original place. That's how it works. So essentially, you're rotating the paper, not how you're drawing on the paper. First, you rotate the paper, make your square drawing in your normal reference. Then you can replace the paper back in its original rotation, back, straight up and down. And what you have a rectangle that's rotated, essentially. All right. So that's what this is doing right here, is just drawing the rectangle after you've already rotated your paper, which is line 44. So that when you restore and everything's going back to normal, you now have a rotated square. Okay, and that's as hard as it is. That's it. We're pretty much at the end. Now we got a test, and I know we're probably going to have some debugging to deal with because of that whole vector issue. But we may... Oh my God, we got lucky. Look at that. That is so awesome. I'm in love. And you notice here that some are spinning faster than others. That was our random generation in the setup function. So they're kind of bouncing off the sides, kind of funny. Here's what I want you to do for your assignment for this part. I want you to figure out assignment 1 on your own. Assignment 2, I want you to make some changes. I want you to do a thought experiment or ask yourself some what if questions. I want you to have fun with it. Really. I mean, think about something that you could do that you would want to do. Maybe change these into circles. That was a joke. Hardy hard. Okay, never mind. Colors. Quantity. Maybe adding, I don't know. There's a couple different things you can do. But what would be the best thing to do is to come up with another what if that you're interested in that may coincide with some of your kind of what ifs that you already have. So add something significant showing your understanding. At the very least, change the colors and turn it in with your own completed solution of assignment 1. Thank you guys. Goodbye.